Okay guys, this is going to be your last video for a little while. We're finishing up this unit, the first half of chapter 8 on convergence of series, of infinite series. The last test we're going to do is called the root test, and it's probably one of the easier. It's middle of the road easiness. It's not as easy as like a p-series, but it's not as bad as an integral test or even a ratio test. So go ahead and pause for a few seconds and write down these rules for the root test. You should see a lot of similarities to ratio test in here as far as the conclusions go. And then, all right, go ahead and pause. If you need a minute, pause, pause, pause. Okay, so you're going to want to use this root test when you see nth powers. So if you get a series whose formula has a raising to the nth power in it, this root test is going to work out perfectly because it's an nth root. That's the opposite of an nth power. So let me just get a quick example or two. How about the sum from 1 to infinity of 2n over n plus 1 all to the nth power. Now, if you look at this and think about it before you start, I realize that we're learning a new test, and we should use the new test for practice. But if you think about these terms, they are approaching, within the parentheses, they're approaching 2. So our millionth term would basically be 2 million to the 1 millionth power. And 2 million to the 1 millionth power is hardly approaching 0. So I'm expecting divergence here, hardcore divergence. But just for practice, we're going to use the root test. One thing also that hopefully you noticed during your ratio test problems, these two tests both have absolute values in them. And that implies that the alternating nature of a series, you don't care about that. You just make it all positive. It's kind of, it's kind of, I don't know, overkill, or it's kind of not necessary to even do these tests if you have an alternating series, because remember, an alternating series whose terms go to 0 converges. And if the terms don't go to 0, then you have no reason to do any of these tests. So we're starting to get to a point where you've learned all your tests, and there's a lot of overlap. And this is a perfect example of how you would not need to do the root test on this series because the terms do not approach 0. And alternating series, that happens a lot on because they converge very easily just because the terms go to 0. Anyway, back to the root test. Basically, I just need to take the limit as n gets big of the nth root of my formula. And since my formula is to the nth power, I end up just taking the limit as n gets big of 2n over n plus 1, which is 2. And since 2 is greater than 1, this diverges. Easy test. Let's do one more example here. How about the sum as n goes from 0 to infinity of e to the negative n. Okay, so I see I see an nth power, which makes me think, hey, root test might work best. The terms are approaching 0. This is one of those things that's confusing, but this is e to the negative n equals 1 over e to the n. And as n gets big, those terms definitely do go to 0. So let's see, my test is going to look like this. The limit as n goes to infinity of the nth root of, I'm going to go ahead and put this on the bottom because I'm doing an nth root of a negative nth power, and that kind of, I could have put it on the bottom later, but I'm going to write it as 1 over e to the n instead of e to the negative n. That just makes both of my n's positive and kind of makes it work out nicer. So I end up taking the limit as n gets big of 1 over e. N through the 1 is always 1. The N through the V to the N is E. Now, this expression that's left here, it doesn't have any N's in it. So no matter what N does, I always am left with 1 over E. Okay, so how big is 1 over E? Well, I don't really know how big it is, but I know it's like 2.7 or 2.17 or it's 2 point something. So this number is less than 1. So it converges, and technically it's like the ratio test. It converges absolutely also, which just means it converges not only because it alternates, and this one doesn't alternate, but a series that converges absolutely converges whether the terms are alternating or not. Okay, so we're going to have a record short video. This is the root test. I told you in class, test is a week and a day from right now. So you had a short video, so I'd encourage you to look through some problems, go to the review problems at the end of the chapter, and just pick some tests or pick some series and see if you can tell do they converge or not. There's plenty of resources out there. Google infinite series, and you'll find 8,000 examples that you can look at. But be disciplined and study a little bit all through this upcoming week, and your test will be a lot more of a pleasant day for you. So anyway, 8-6, last video for a little while.